This is the Liac Light Intra-Operative Accelerator, produced in the Sordina SPA factories of Padova, Italy. The machine has freedom of movement of 5 degrees, 2 on the floor surface and 3 degrees on the radiant head. The head rotates on a horizontal axis crosswise to the machine body with a movement called pitching, and on a horizontal axis lengthwise to the apparatus, which is called rolling. The column that lifts and lowers the radiant head has 1 meter excursion. The machine moves forward, backward, and laterally with a rotation radius of 1.5 meters. The machine reacts to the operator commands. One operator is enough to maneuver it with maximum immediacy and the most controlled flexibility. In fact, it is expected to be used in the surgery theater, where normally the space is a precious resource. It enters and exits standard doors very easily, as in an apartment doorway entry. And also, being destined to operate in hospitals, it can be comfortably loaded onto an elevator that accommodates gurneys. It is extremely precise with excursions that can be executed in all directions in terms of fraction of millimeters. It has safety measures put into place for all of its movements, and the exterior is protected and reinforced in all of its parts. Its commands are intuitive. There are few arrows in the remote control, and it is very easy to use. The machine is very light when mobilized. It is never heavy. The wheels that sustain it and the infinite screws that animate it from the inside delicately articulate it with the most efficiency.
Il Liac è un acceleratore di elettroni.
The Liac is a mobile accelerator specifically designed for e-IORT, intraoperative radiotherapy treatments that are executed through delivery of a single dose of radiations during the surgery, immediately after surgical removal of the tumor. The main characteristic of the e-IORT is the delivery of a high dose to the target volume, sparing the healthy tissues and the organs at risk. The advantages of e-IORT on the conventional radiotherapy are several. The tumorous bed, after the removal of the neoplastic mass, is directly exposed to the radiation beam. Through the surgery breach, it is possible to check the area to be treated. The applicator is directly positioned on the target by the surgeon. The inaccessibility of the target in radiotherapy is no more a problem. It is possible to shield and dislocate the organs situated in close proximity of the neoplastic area, minimizing irradiation of the healthy organs. The absence of the healthy tissues between the radiation source and the tumor area overcomes the problem of the limit to the dose prescription. The unique session eliminates and significantly lowers the patient stress. It is possible to execute the radiotherapy treatment in cases where the standard techniques with external beams are not applicable. Among the mobile accelerators specifically designed for e-IORT interventions, the Liac is today the one supplied with the highest energy contained in the least volume. The weight of the mobile unit is about 400 kilograms, even 4 times less than that of several machines destined to do the same work. Dimensions: length 230 centimeters, minimum height with radiant head in transfer mode 185 centimeters. Maximum width 76 centimeters, radiant head movements, lifting 100 centimeters, pitching from plus 30 degrees to minus 15 degrees, rolling from plus 60 degrees to minus 60 degrees. Consider that the Liac works with any type of electric monophase standard, with power absorption extremely restrained, less than 2.5 kilowatts. The applicators are realized in PMMA, polymethyl methacrylate. This means better cleanliness and sterilization according to the best established current practices, cold plasma sterilization. As they are transparent, the applicator is allowed to observe and possible bleeding and enable to visualize the surgical breach even after docking between the applicator and the radiant head. The field involved can be photographed for documentation purposes when the applicator has already been placed on the part to be irradiated. The applicators are available in 7 dimensions. The 120 mm diameter is supplied on request, and in 4 angles, 0, 15, 30, 45 degrees bevel. If you also consider the 4 energy levels currently applicable, the different fields where the irradiation intervention in the surgical breach can be arranged are 112.
I nostri dischi di radioprotezione dei tessuti sani nel trattamento IORT della mammella. Sono un brevetto Sordina e sono...
Sordina has developed and patented its own revolutionary disc, manufactured in 6 measures. Specifically designed for the protection of healthy tissues in the e-IORT treatment of the mamma carcinoma, they are perfectly biocompatible and must be positioned in the surgical breach without any supplementary protection. They result from 2 layers of different materials in order to optimally shield the beam: 3 mm of PTFE and 3 mm of stainless steel, assembled to obtain a single disc composing of a Teflon side and a steel side. Having put the disc in the surgical breach with the Teflon side turned upwards at the depth corresponding to the 90 degrees of isodose, and fasten it with very small stitches by means of the 4 holes made on the disc itself.
Quindi la scelta di questi materiali permette una buona attenuazione.
The beam appears to be appreciably minimalized. After each use, the disc, separated in its 2 sections, can be cleaned and sterilized, decontaminated in a proteolytic substance bath, then sterilized in an autoclave at 134 degrees centigrade. The collimation system is of the hard docking type. The applicators are rigidly linked to the accelerator. A collimator is then made up in 2 parts: a proximal applicator coupled to the accelerator head through automatic fastenings, and a distal applicator, the one in contact with the patient on the surface that must be irradiated, fastened to the proximal applicator. A most important consequence of all of this, and an excellent outcome of the global constructional strategy that drove to the designing, manufacturing, and further improvements of the Liac, is that the treatment has a very short duration, lower than 2 minutes as a roll, which is obtained thanks to the high doses deliverable in conditions of the highest safety. In the last version of the Liac, a monitor unit with reference fields corresponds to 1 CGY at Dmax, such as in the conventional accelerators. Besides, the architecture of the radiant head and the collimator system have been thoroughly simulated utilizing Monte Carlo codes. A software has been then developed in collaboration with the Rome Regina Elena Institute that, based on these simulations, global reconstructs the dosimetric characterizations for all the applicators and all the energies available, so dramatically reducing times and uncertainties of the commissioning. Now the Liac is able to treat its first patient just a week after its arrival at the hospital. The Liac, manufactured by Sordina today, is an operative machine, closest to the operator's sensitivity and at the same time to the final user's preoccupations and needs.